Hi math students, we are now on project 4 and we're on lesson 16. So let's go ahead and begin. We've got 6 questions in this first lesson, so it's a big one. While gathering and processing evidence, crime scene investigators use various types of data to help solve criminal cases. Finding patterns in the data can lead to new discoveries, which can help to eliminate suspects and single out the culprit. As you may have noticed, sequences and functions can be analyzed to identify patterns. Use your knowledge of functions to answer the following questions, which are related to evidence taken from crime-based scenarios. Okay, so the first one we have is the function f of x equals 13x plus 42 represents the number of inmates that pass through a city prison, where x is the number of weeks that have passed since the prison started recording data for the study. What is the domain of this function? Okay, well, natural numbers are whole numbers that don't include 0, and they are greater than 0. So 1, 2, 3, 4, those are natural numbers, okay? Real numbers can be negative numbers. They can be rational and irrational numbers. They kind of encompass everything. So in this case, we can have 0. If we put in 0 for this function for x, we'll end up with the function being equal to 42, which is it's what it would be at the first week. So natural numbers don't qualify here. But negative numbers won't work here because x represents the number of weeks. So we can't have a negative number in here. What I'm getting at here is that all natural numbers won't work and all real numbers won't work, but all real numbers where x is greater than or equal to 0 would indeed work. Where this one is x is less than 0, so that would be negative numbers, and again, we can't have negative numbers for time. So the second choice there is our only real legitimate answer. Okay. Next question, how many inmates passed through the prison after 7 weeks? So what we need to do here is go ahead and plug in 7 for x. So we say f at 7 equals 13 times 7 plus 42. Well, 13 times 7, 20 is 91 plus 42. Okay, so 133 inmates passed through the prison after 7 weeks. Okay, we're moving right along. In another city, the number of inmates that passes through the prison is represented by the function g of x equals 9x plus 51. What function represents the total inmates that pass through both prisons? So if you'll recall, we had f of x equal to, let's just make sure we've got it right here, 13x plus 42. Well, fortunately for us, if I want to get this composite function, all I have to do is add these together. H of x equals 22x plus 93. 1 and 2 is 3, 5 and 4 is 9, and 9 and 13 is 22. So h of x equals 22x plus 93, which is right here. Okay, so that does make sense. That's the combined rate and starting point of the two prisons together. Okay, the parole board is looking at inmates in a certain cell block to see if they are due for a parole hearing in the next year. Inmates with more than one prison sentence are unlikely to be released early. The chart below shows a group of inmates and the number of months in each prison sentence. Each inmate in cell block D has a unique ID number. Okay, so which of the following elements are in the domain for this relation? So if we were to graph this, these would be our x values and these would be our y values, because these are our independent values and these would be our dependent values. Okay, so our x values are always our domain and y values are our range. Okay, so our domain values are going to be 103, 410, 838, 027, and 317. Okay, they're just the values that are listed right here. That's our domain. Okay, question 5. Similar question. And again, it wants to know which are the domain. So we've got group B here. So again, we have X is the domain and Y is the range. Okay. So if we scroll down, we'll see that our domain values are 082, 101, 345, 101 again, and 618. Okay, that presents us with an interesting situation. Our domain has 1, 2, 3, 4 values, but 5 values were listed here. 1 was repeated. Okay, so that's a very interesting piece of information. If we go down here to question 6, it says, although the charts for group A and group B are both relations, only one of them is a function. Which relation is a function and why? Why is the other relation not considered a function? Okay, well, remember, if you're going to have a function, you can only have one value of y for each value of x. Okay, if we go up here to group B, well, let's see. If we go here to group B, we can see that we have, well, I'll go ahead and draw here. Okay, we've got one value for 082, but for 101, we've got two different values of y. Okay, I've got the same x value, but I have two different values of y. And what that would look like on a graph, if I have 19 and 21, I would have a point here and a point here, and it would make my function, if it was going along like this, it would make my function go like this. And my function then would not pass a vertical line test because it has two y values for this one value of x. Okay, so group B cannot be a function because there are more than one y value for the x value of 101. Group A is a function because there are no repeated x values. Okay, so this is what we'd type here. Group A is a function because there is only one y value for each value of x. Another way to say that, there's only one range value for each domain value. Okay, group B is not a function because for the domain value of 101, there are two range values, and it would not pass the vertical line test. Okay, so that is why that is not a function. Okay, we have quickly made it through 6 questions here. Thanks for taking the time to listen, and I'll see you when you're ready to do lesson 17.